I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
or
space, time,
the brain,
life, the universe.
It's The Naked Scientists, and this week, is the sugar in fruit any better for you than a donut? How do reflective jackets work? And why do bright lights make some people sneeze? Hello, I'm Chris Smith. This is The Naked Scientists, and this week we're tackling the science questions that you have been sending in.
The Naked Scientists podcast is powered by ukfast.co.uk.
With us this week are Liliana Fruck. She is a Cambridge University chemist, and you're also going to be a restaurateur pretty soon. Isn't that right? You're opening a restaurant in Zagreb.
Yes, and it's going to be based on my chemical knowledge, which I'm not saying to the customers, though.
Really?
Well, it's going
what are you going to cook up for them?
Well, we will explore how to use the proper ingredients to get the flavors out. And we will use some historically relevant recipes that have been forgotten as well.
But haven't been cooks and decent chefs been doing that for years anyway?
Well, yes, but we are developing a new methodologies as well, because we are going to use biomaterials as well to produce some stuff. So I think you will need to come to visit us.
Liliana Fruck, any question on chemistry, she can answer it for you. Sam Virtue is a physiologist in Cambridge, and his role, he looks at the metabolism and also how we break down fat as a day job. Must be exciting. Food for thought.
Yeah, I mean, the tissue I work on is one that I think a lot of people just think it's a dull, white, amorphous blob that they might trim off their Sunday roast. But actually, I think fat is the most exciting tissue in the body. And so that's certainly what I do every day.
There's a lot of myths around food and food science, though, isn't there?
Yeah, and I think the myth that I would like to really try and highlight to everyone, and one I would like to bust, is that there is something special about different diets. So you hear this paleo, the Atkins, the 5-2, and there are wonderful claims made for how they work, but they all work based on the laws of physics. You lose weight if the amount of calories you consume is less than the amount you burn, and every single diet works the same way.
Sitting next to Sam is Tim Revel. He is a mathematician, now turned tech journalist and former naked scientist. Tim, welcome back. Great to have you with us.
Thank you. Always good to be here.
Anything crossed your desk on the tech world that you...
Well, something we've been talking about a lot recently is SpaceX, who is Elon Musk's space company, and they sent up a rocket to the International Space Station, which is the first time a private company has ever done that. And so in the next year, we're expecting they will be the first company to ever send humans up to the International Space Station, which will be a big change. Previously, it had been NASA or the Russian Space Agency or other space agencies, but now it will be the first time that a private company is doing it, and I think that's pretty exciting.
Thank you, Tim. So any questions about maths, tech, they can go Tim's way. Sitting on the opposite side of the room from Tim, Adam Murphy, our own space and physics guru. Welcome, Adam.
Hello, how are things?
Yeah, it's good to have you on the programme. What have you got in front of you?
So I have...
This is a trick. It's not a trick. I've actually put some things in front of you. Would you like to explain what they are?
Yeah, I don't know why they've been put in front of me. I'm sure I'll find out. So I have 3 jars. One is a jam jar. Then I have a Tupperware thing full of rice and another one full of walnuts, I think.
Indeed. Now, what we have is an experiment for everybody at home and here in the studio that we want you to have a go at. We're going to explain the physics and the maths behind this later on. It's very easy to do, but the result is really very surprising. So here's what I want you to do, Adam. You can set this up now.
Right.
Take the nuts and put 2 or 3 in the bottom of your jam jar.
Right. Container open. Lid off.
So that's 2 or 3 walnuts. They're going in the bottom of the jam jar. Now I want you to about half fill the jam jar with rice.
Right. So rice lid off.
This is not cooked rice, I hasten to add. This is raw, uncooked rice, white rice.
Hopefully not all over the desk. Okay.
Right.
Only
now,
a few bits lost.
Put the lid back on, please, so we don't make a mess. And what I'm going to ask everyone at home to do who's doing this is to give it a really good shake. We'll do it later in the programme, so save that for here, Adam. But everyone at home, give it a really good shake. Something really surprising will happen. You will be quite shocked. Now, while you're experimenting, maybe you'd also like to try and identify this creature for us. We do this every time we do one of these Q&A shows. We give you a series of clues through the programme where we reveal a little bit more about this mystery creature every 15 minutes or so. And hopefully by the end of the hour, you'll have worked out what this is. So here's your first clue. We are mainly between 3 and 15 centimetres long, and we have a tail that's half as long as our bodies. Any ideas? Don't worry if you're completely clueless at this stage. More clues coming up later in the programme. In the meantime, Sam, got a question to start us off. This one is from Annie.
Is the sugar in fruits any healthier for you than the sugar found in things like donuts and cake?
So what do you think?
Well, the answer to that is no, simply. And in fact, actually, some of the sugars that are commonly found in fruit might actually be worse for us than those found in donuts. In particular, a sugar called fructose, which its name comes in part from fruit. And so whereas donuts will be made in the UK with your classic Tate & Lyle white granulated sucrose, fruit will contain a sugar called fructose, and this fructose has been shown in particular to be very harmful to our livers. Now, it does have some advantages, which is maybe why it's not quite so bad for us unless we take huge quantities, which is that it's sweeter than things like sucrose and glucose, so you maybe need less of it. Although that would appear to suggest donuts might be healthier than fruit, the truth is very different because whilst a donut might have slightly healthier sugar, it does have vastly more of it. A normal-sized apple has about 19 grams of sugar, a donut has 48, but also the donut contains piles of fat. So one normal-sized apple has maybe 95 calories. A donut would have about 800 if it's the same size, so you would need to eat, 8 apples to get about the same amount of calories. So,
Liliana, fructose.
And it's so nice that you said that. Yes. But it's very nice that you mentioned apples because there is one myth I want to enhance. Because I've just learned that you should really eat an apple a day to keep the doctor away because the apple peel contains a compound which is called quercetin. And it has been found out that this quercetin, if you give it to aged mice, they can actually become younger. Their cells become younger.
Is it antioxidant or something?
Well, it's antioxidants, but it's also something called an antisenolytic, which means that it removes senescent cells, which are a normal product of aging. They're also called zombie cells, funnily, because they have enhanced metabolism, but they don't divide. And this quercetin from apples seems to be kind of removing these senescent cells and allowing normal, healthy cells to grow better.
So we should be saying an apple a day keeps dementia at bay rather than a doctor away.
As well, yes.
But going back to your point, Sam, about the fact that there is a lot of sugar in fruit, why is fruit beneficial then? Because if you look at all of the data that we're being fed, excuse the pun, on a regular basis, we're being told eat your 5 a day, and that includes a healthy portion of fruit. So why is that good?
Obviously, as part of the advice on eating 5 a day, there is a focus on eating a lot of vegetables as well in there and trying to not have too much fruit as your component of your 5 a day. For example, only 1 helping is suggested to be fruit juice. And again, that's because of the sugar which you're trying to limit. But what fruit does have lots of great things in it are things like vitamins and minerals. And if you're going to eat something sweet, because we all have to have some enjoyment in our lives. We can't just all eat things that we think are boring and savoury. If you want something sweet, it's not about the fruit is necessarily good. It's the fruit is sweet, which is nice for you, and it's not as bad as a donut.
Tim looks relieved. He's allowed the odd treat. You looked terribly pleased when he said initially, there's loads and loads of sugar in the donut and the fruit isn't actually much better than the donut. And you went, excellent, I saw your face. And then when you said, actually, it's not that good, you look really upset.
Well, the thing is, donuts are amazing. And whilst you were talking, I was just wondering, why can't we make something that has all the benefits of fruit, but tastes as delicious as a donut?
Well, we'll pause on that point and let that sort of ferment for a little while you answer this one for us, which actually has been sent in on our forum, nakedscientist.com/forum. It's from Scientist, who says, how does a fingerprint reader work? And where do you find them? Are these on devices like my mobile phone, I suppose he's mentioning?
So you get them on mobile phones, you also get them in police stations, and they all rely on the fact that everyone has a unique fingerprint. And these, if you look at your fingers, you can see that these are a sort of series of ridges and valleys that are characterized uniquely to you. And the way that any fingerprint scanner works is it tries to take an image of that in various different ways. So, for example, some fingerprint scanners are basically just cameras. They take a photo of the edge of your finger and then they compare it to other photos of other people's fingerprints. But on your phone, for example, most phones use something called a capacitance scanner. And what this is it's loads of little squares in a grid that when you put your finger on them, they produce a little current. And the current reacts slightly different in the ridges than it does in the valleys. And that produces a measurement that it can use to sort of uniquely identify you.
Adam?
Is there any way to fool them? Like, can you tape a bit of sellotape to someone's finger and put it on the scanner and break in?
The thing is, fingerprints are very intricate. In theory, it is possible to do that, absolutely. And the software that analyzes fingerprint scans is not perfect. It doesn't do a perfect image comparison between you and whatever fingerprint it's looking at, especially because when you're putting your finger down on a fingerprint scanner, you don't always use the same bit. You do it at a bit of a funny angle, and that gives a slightly different measurement. So that means, in principle, yes, you can trick them, but it's really quite hard to imitate someone else's fingerprint.
Thank you very much for that, Tim. Quick one, just to revert back to the point you were making about fruit, Sam. Rosemary's been in touch and says, can I get all the good things that apples do for me when I microwave them and bake them in the oven? Do they have to be raw, for example?
So I don't know the specific details with the apples, but there are certainly some vitamins and minerals that will go away with cooking. And this is why cooking processes which are less stringent, perhaps, so, for example, steaming rather than boiling, they will lead to less of the vitamins and minerals being leached away. So that is certainly the case that you can get a lot of benefit from it, but there may be some things you lose.
So cook with care.
Indeed.
But
gently.
obviously cooking is good because it kills microorganisms and bad-for-you things that are in there. So there's a toss-up, I suppose, between the benefits of releasing more calories by cooking and sterilising your food, but at the same time you end up with a higher loss of the good things like vitamin C.
Yeah, absolutely. And I think the benefits of cooking historically were vastly greater than perhaps they are now. I mean, there's certainly certain things that you would absolutely not want to eat raw even to this day. But a lot of things like fresh fruit and fresh vegetables, we think about going to the supermarket and being a beautiful apple. Well, if you're living through winter and you don't have refrigeration and you've got a bushel of apples, then it's a little bit of a different situation maybe 200 years ago.
There's also cyanide, amygdalin, which is in the seeds of apples, which is not quite so good as the skin you were mentioning, Liliana. I think I calculated that you'd have to eat about 54 kilos of apples before you actually got a fatal dose of amygdalin to wipe out a human. But there is still cyanide in the pips, so maybe don't eat the core. But we had this question come in, which is a very good one. It's from Sam, who said, you sometimes see cyclists with super reflective jackets on. First of all, how do these super reflective jackets work? And why do the colours seem much more vibrant at, say, dusk, and more so than during normal daylight or at night time? How do they work?
Yeah, it's an interesting question as well. So the super reflective jackets are, of course, relying on fluorescent dyes, which are embedded in these jackets so that you can, when you are driving your bike during the daylight, you can be noticed, because fluorescence is the strongest in the UV light during the daylight from the sun. And then you have reflective materials, which are basically reflecting the light that is coming from the car, from your jacket. So the question, why do you see these colors a little bit better in the dusk or dawn and not in the daylight, is basically also related not only to the colors which are in these jackets or materials, but also in the way how we see. So the contrast is going to be much higher also when you are changing the daylight to dark, because we also have in our eyes, this is really interesting, two types of the cells that are activated during the daylight, and then there is a second type of the cell that is activated during the night. And
these are the rods and cones.
The
rods
yes.
are useful during dark and low light conditions. The cones see colour and are much more active in the daytime.
Exactly. So, there is this activation process that is also happening when you are changing the light and night. So it will be a combination of the materials that you are using. So you have fluorescent materials and reflecting materials, but you also have this contrast that you have around the surrounding lights as well.
How do they get them so reflective, though? They're just amazing, some of these materials. And there's someone who came into our office the other day and she had a coat that looked just grey. And as soon as you shone light on it, or when I noticed her cycling home in the evening and I came along with my car behind her with the headlights, no chance of missing her because she glowed like a beacon. It was bright white.
Yeah, it's amazing how they improved. And of course, today we can have different kinds of materials that have structures which are nicely aligned, so the light will basically reflect totally. And I mean, in nanotechnology, for example, is very interesting because we are designing materials that can be so nicely structured that they not only change with the light that is coming, so they can be super refractive or they can be super absorbing, but they can also change with the change of temperature or the humidity that you have in your environment. So that the material properties are getting much better and we have better ways of aligning them.
Well, you mentioned the very small and down at the nano level.
Yes.
We want to go even smaller than that now, Adam, because Rehoboth has got in touch via email to chris@thenakedscientist.com and says he wants to know, can atoms actually be destroyed in any way, or are they literally there indefinitely?
It depends sort of on what you mean by destroy. If you just mean break it up into bits, then yeah, you can. A lot of the history of science has been, oh, we can't divide this thing any further. Oh, no, wait, yes, we can. Like atom comes from the Greek meaning indivisible. But we've learned that we can break atoms up into protons, neutrons, and electrons. We've learned that those can be divided further into things called quarks. And so far, we think that's the bottom layer, but we could be wrong again. But there's another layer to that, which is if you go to Einstein's work, you get his big famous equation is E equals mc squared. Energy is mass times the speed of light squared. Basically, energy and mass are the same thing. So you can convert mass into energy, and there's a lot of energy in a tiny amount of mass. If you took 1 kilogram of stuff and converted it all into energy, you'd get about 25 billion kilowatt hours. If you took 1 gram of stuff and turned all of that into energy, that's what happened at Nagasaki in 1945 with the atomic bomb.
So one tiny component of you could destroy an entire city if we realised all of the energy that's in it. But you mentioned radioactivity because that bomb was the process, that was a nuclear bomb, which is, in some cases, you make a nuclear bomb by splitting atoms apart to actually make them fall apart. So atoms can, in that sense, be destroyed, can't they, if they radioactively decay? Other bombs are made by joining atoms together to make bigger ones. So we can actually take one atom and turn it into another kind of atom by radioactivity.
Absolutely, and you'll find if you take those 2 atoms and smash them together, that new atom will be a tiny, tiny bit lighter than the other 2 put together because that little bit of mass is turned into energy.
Adam, thank you very much for making that atom easy to understand. You're listening to The Naked Scientist with me, Chris Smith, and this week we're answering the science questions that you've been sending in to us. On the way, how can I have warm armpits and cold feet, but at the same time? And should I be worried about electromagnetic fields? Stay tuned. Meanwhile, don't forget we're asking you to experiment alongside the programme. Very easy this. You just go and grab a jam jar, empty, tip in some walnuts or other big nuts. Some big nutty thing will do. 3 or 4 of those. Fill it about halfway with dry, uncooked rice. Put the lid on and give it a really healthy shake. What do you see? You will, I promise you, be very surprised. We've got one here in the studio. We're going to explain why that works and also what's important, why it matters in the real world, coming up later in the programme. Here's the next clue in our What Am I quiz. I told you at the beginning of the show that these things we're asking you to identify are mainly between 3 and 15 centimetres long. They have a tail about half as long as their bodies. Sam is doing a measurement in front of him with his fingers to work out roughly how long it is. Have you got any idea what the creature might be, Sam?
No, sadly we haven't been given the answer in advance, so I can't sound like
No. Well, you're going to have to work it out. OK, now here's clue number 2. We are on every continent apart from Antarctica. Got it yet?
No.
No. Don't worry. Everyone's baffled. More clues are coming up. Now, Sam, putting you in the firing line, Jake's been in touch. He wants to know why some people sneeze when they look at bright lights. Why could that be?
Well, this question is intriguing to me because I am one of them. And this is a well-described phenomenon. It's called the photic sneeze reflex, or, because scientists are funny, autosomal compelling helio-ophthalmic outburst, or achoo. So this is a classic science joke.
Is that real? Is that what they really dubbed the syndrome?
It.
Brilliant.
Yeah, they literally did that. Essentially, it's the phenomenon that when we stare at a bright light, we sneeze. So why this happens, we're not 100% sure, but there are other examples of this where it's essentially a bit of miswiring, whereby your body has one sensation or one stimulus and it results in something strange happening. one way it's thought to possibly happen is the nerves that are essentially responsible for sneezing are also the same nerves which go to our eyes, called the trigeminal nerves. But actually, I thought it was just a thing that happened, but it actually has a couple of major issues. So the first one is fighter pilots, if they are flying in to land on an aircraft carrier and it's late evening, the whole sea will be lit up as a brilliant shimmering light, and they will sneeze if they have this, which will quite possibly result in them crashing into the sea.
Well, when you're doing a few hundred kilometres an hour, that's
And
not much margin for error.
Yep. The Navy came up with an extremely high-tech solution to this. Aviator sunglasses. Yeah, wear some shades and you no longer have as much light. But the one that's really terrifying, and actually I'm not sure that this is safe before the watershed because it makes me cringe so badly, is if you are undergoing eye surgery which requires a needle to be put into your actual eyeball, they use a sedative called propofol. And the combination of propofol and putting a needle into your eye will trigger this. So surgeons doing this will generally insert the needle and then withdraw it, because if you sneeze violently with a needle in the middle of your eyeball, yeah.
Should have gone to Specsavers.
Yeah.
Adam.
I'm going to shudder for a moment about the eye thing, but how common is this? Because if you do it and I do it as well, so is it
Well,
a
I
very
do
common
it,
thing?
so that's three of us out of... You Liliana?
Yeah.
Tim, are you a
Not me.
sneezer? No photic sneezing
I don't
for
know
Tim?
what you're talking about.
Okay, so we're slightly overrepresented here, but it's thought to affect between 18 and 35% of the population, so it's certainly not rare. Things that make it worse, for example, and particularly trigger it, I actually used to think it was alcohol was one of them, because I would suffer
From personal experience.
from personal experience. But it turns out that's just a product of Cambridge having lots of dark old men pubs, because sudden transitions from dark, dimly lit areas to brightly lit areas will trigger it particularly powerfully.
I've found it's really useful, this, when you have that horrible thing that happens to you and you want to sneeze and you can't. Well, because I have this and I know this, I facilitate a sneeze that I want to get out by looking at a bright light. And then you're nodding, Adam. You do the same. You do the
Exactly.
same trick.
It makes me look really weird, but it's really helpful.
Stare at the bright light and then achoo, off you go. And that feels so much better. Liliana.
Yeah, I just wanted to tell you, actually, Sam, I discovered this a few years ago. I didn't have it before, so it's something that developed relatively recently. So it's an interesting fluke of nature, of biology.
Another weird one is people who stick something into their ear to clean it out. About 2.5% to 3% of the population develop a cough reflex because there's Arnold's nerve in your ear, and when you stimulate it with a cotton bud, you will get a coughing fit. And many people who have this think they're totally mad. You're not. You're just one in about 50 who have this. Now, Tim, non-photic sneeze reflexer. We've got this question for you, which has come in from Alistair.
What is the science behind smoke detectors? How do they actually work?
So smoke detectors are actually one of those things that most people ignore. You sort of stick them up on your ceiling and then you never think about them again. But actually inside those fairly plain white boxes, there's some quite cool science inside them. So there's two main ways that they work. The first is called an optical smoke detector, and essentially these have a little LED light that fires out a small light beam, and there is also a solar panel similar to what you might have on your roof. Now, if there's no smoke, this light never actually touches the solar panel, but as soon as smoke enters it, the light scatters, hitting a little bit of the solar panel, creating a little bit of electricity and triggering the alarm, which is, if you've ever heard one, incredibly annoying and enough to make you get up and check if there's a fire. The other type of detector is called an ionization detector, and these are also pretty cool. So there are two metal plates, and there is also a small radioactive source that produces particles called alpha particles. These what's called ionize the air in between the two plates, which essentially means that you end up with an electrical current between the two plates. Now, if everything's functioning normally, this electrical current just keeps happening and it's not interrupted. But as soon as smoke enters the gap, you no longer have the electrical current flowing, it triggers the alarm and off it goes, and the same thing happens as with the other type of detector.
Indeed, I think it's americium is the alpha source that's in your average smoke detector. Is quite radioactive, isn't it? It's quite amazing that everyone's got this radioactive source in their roof, so don't play with it, I think, is the bottom line, isn't it?
Yeah, it's quite radioactive, but it's these alpha particles don't travel very far. You don't need to worry about it, so it's not like they're producing gamma rays or something that could actually harm you from the ceiling, so they never actually escape the little box that you keep them in.
Thank you, Tim, very much for laying that one to rest. Now, Liliana, got a question here from Ranjay, who has been in touch and says, what material changes colour when you heat it and it reverses back when it cools down? You see this used in things like cups and mugs when they have pictures on them that disclose a different image when you put the hot fluid in, or children's knives and forks and plastic spoons, for example, to make dinner times fun. How do they actually work?
Actually, I do have one of these cups. I love it.
You've got
because
one.
when you put hot tea in it, you see this dinosaur suddenly appearing, in the cup, which is really beautiful. This kind of materials have been around for ages, and they can be of two types. So the one which is used in cups or some toys, it's made of organic dye, which are called leuco dyes. So basically they have structure which is changing with the heat. So they can be, for example, transparent because they don't absorb light, and then you heat them up, their molecular structure changes a little bit, and suddenly they can absorb light of a different wavelengths. And you have many different kinds of dyes, so you can basically draw these patterns on your cup, and the moment you put something hot into your cup, it will change the color. Usually they are not very sensitive, so they will just detect hot or cold, and that's why you would use them for these materials. But if you want to be a little bit more precise, you might be using liquid crystals, which are more expensive. So they can also be made of some kind of organic molecules, but they are assembled in a particular way. And as you are heating them, you are changing their assembly, you are changing their structure a little bit, so they interact with the light in a different way.
Tim?
So are these materials used for something else? Because they sound amazing, and then a mug is a fairly underwhelming use of such an amazing material.
Yeah, well, they are. I mean, liquid crystals are used in monitors, in lots of sensors as well. So we use them continuously. So you have LCD displays. They're liquid crystal displays. So you use them in technology and high-tech industry quite a lot. I mean, you would not probably use liquid crystal to make a cup because it would be kind of expensive. But what is also really interesting is something that in biology, liquid crystals are often used. So, for example, materials which are similar will be used by lizards, for example, or some types of birds. They also have particular structure which can change, and then it will change the color. And this can be with the humidity or the temperature. Or even octopus, which can camouflage itself very well, uses some kind of structural materials that change with impulses. It's all kinds of materials that are really useful.
Thank you, Liliana. So there you go, Ranjay. Basically, a molecule that when you heat it temporarily changes its shape, and that change in shape means it interacts with one colour of light but not another and reflects a different colour temporarily, which is why the colour appears to change. When it cools down, flips back to how it started, and that's why you get your original colour back. Are you going to have that in your restaurant, that colour-changing cutlery?
Actually, I am talking right now to a chemist at the University of Cambridge to give us some of the structural colour to decorate the food. You can have an artistic display on your plate. So
I can't wait.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
You're listening to The Naked Scientists with me, Chris Smith, and this week we're answering the science questions that you've been sending to us. Speaking of which, if you'd like to send a question in for one of these programmes, it's chris@thenakedscientist.com. We'll also pick them up from Twitter @Naked Scientists or via our Facebook page. With me are chemist Liliana Fruck, physiologist Sam Virtue, mathematician and tech journalist Tim Revel, and physicist Adam Murphy. Don't forget, we've also invited you to experiment alongside the programme this week. You put a handful of something big like some walnuts or Brazil nuts into the bottom of a glass jar, half fill it with rice, put the lid on, give it a really good shake. Some serious science there. We'll explain it later on in the show. Now, you guys have done a wonderful job so far answering everyone else's questions. Now you're going to answer some for us because it is the quiz. And this is where you compete for a prize beyond price. It's the Naked Scientist Big Brain of the Month award. Our two teams will be Liliana and Adam on Team 1 and Sam and Tim on Team 2. Round 1 is called More or Less. Liliana and Adam, what weighs more, a polar bear or a Shire horse?
first of all, Adam, what is a Shire horse?
So Shire horses are those giant horses you see police officers riding that are very scary.
Okay. Okay.
But polar bears are also equally large and very scary.
Yes, and they have lots of fat. They need to have lots of fat to keep them warm. Is the fat heavier than the muscle?
Gonna have to hurry you.
Okay. What are you?
Horse, I think.
Horse?
Because I
You
think they
think
might be trying to
horse?
trick us. I'm going to go with horse.
You're gonna
Okay.
You're going horse.
Yes. Okay. I will agree.
Indeed, a polar bear weighs in around 720 kilos. Shire horse, a massive 900 kilos, so just shy of a ton. So they're very, very big. Okay, team 2, Tim and Sam. Which costs more? A kilo of human blood to obtain, as in, like, for transfusion purposes. I mean, we could get a kilo in here if we wanted pretty cheaply, but this is transfusion purposes. Or a kilo of tobacco. What do you think?
Oh, that is a tricky question. Is that wholesale price or after tax?
Yeah, I was thinking the exact
Or in your
same
suitcase
thing.
back from the continent, Tim?
Yeah. It feels like it should be the blood, doesn't it?
That's more expensive.
Yeah,
Yeah,
it kind of
I would
feels
go
like-
with that as well. So no is the answer to that.
No is indeed the answer to that. So 0 for you. Blood costs about £275 a kilo once you've done the whole collection process, the purification, storage, etc. Tobacco, though, right, is more expensive. The price of tobacco is double that. So it's about £500 for a kilo of tobacco. So you're not doing so good. Right, okay, back to Team 1, who's Adam and Liliana. You're in the lead with 1 point so far. This round 2, is called Tech Yes or Tech No. Did you see what we did there? Can't take credit for that. Izzy Clark came up with that. But are these ridiculous technologies tech yes or tech no? In other words, are they ones we made up earlier or do they really exist? So team 1, tech yes or tech no, a Darth Vader face mask so that people can not hear your private conversations in public places. It bleaches them out by playing sounds of animals, ambient noises, or even Darth Vader effects while soaking up the sounds you make. What do you think?
This-
Tech yes or tech no?
This is probably yes. This exists.
I will never underestimate people's ability to create
Exactly.
weird things.
Yes, and particularly Star Wars inspired.
Star Wars,
Geeky
yeah,
stuff.
absolutely. Yeah.
So what's it to
So
be?
we think this exists. Yes.
You're on fire. Yeah, okay, that's +1 to you. Yes, the Hush Me was born as a crowdsourced funding thing a few years ago. Actually, you close the two halves together round your face, a bit like a clamshell, around the lower half of your face. It syncs up with your smartphone, so you converse in private over Bluetooth with the phone, and this absorbent material soaks up the sounds you're making, and at the same time it plays sounds from the library on your phone into the ambient area so that you can mask any sounds that might escape. So you can actually, if you want to, sound like Darth Vader. The downside of this is you do end up looking like Tom Hardy's character Bane in Dark Knight Rises, so you probably would get 1 or 2 funny looks, but there we go. Team 2, it's all on this. You've got to catch up now, okay, because you're in trouble. Team 2, tech yes or tech no, a gaudy-looking ring that measures how much vitamin D you're making in the sunshine so you can supplement as necessary. Tech yes or tech no?
Oh, I mean, that could exist.
Yeah.
You have tricked us with something plausible.
I feel no. I just in my bones, but I have a get. It's this
I think
thing.
we should trust your bones.
I know, but it's going to tell. I mean, what I'm hoping is like a trick question. And it's a gaudy-looking necklace.
That's it. So it's not a
yeah.
ring, it's a... I
No.
think we say techno.
We're going to say
Going
techno.
Yes.
It's a slight trick, actually, because it is a techno, but it's a real idea. It was called the Helios Smart Ring. It was also put up for crowdfunding with the aim of calculating sun-generated vitamin D, because when sunlight hits your skin, the UV in the sunlight irradiates cholesterol-like molecules in the skin and it produces vitamin D. Unfortunately, for the inventors of the concept, the sun didn't really shine on their funding proposal, so it got pulled. So that is a techno now, but they did raise about $1,000. So it didn't go far enough, unfortunately. Right, so it's 2 points to Team 1 so far, 1 point to Team 2. Round 3, third round. This is called Out of This World. Are you ready, Team 1? Here you go. Liliana and Adam, if an Earth-dwelling naked scientist stands on some scales and gets a reading of 68 kilos, would their mass be greater or smaller on the moon?
I'm relying on you, Adam.
Hang on, their mass stays the same. Their weight would change,
Change, exactly.
but the mass would stay the same.
That's
So
true.
Go with no.
Yes, we say it's not going to
You're
change.
going to say same.
Yeah.
It was indeed a trick question. Their mass, the amount of stuff they're made from, would, of course, be the same anywhere in the universe. Their weight, on the other hand, which is the effect of gravity acting on their mass, is what we measure when you put a mass on some scales, and that's going to be a lot less on the moon than on Earth. In fact, about a fifth of the weight, but the mass would be the same. Well done. 3 points for you. Do you want the last question, Team 2, just for the sake of... Because you have actually lost, unfortunately.
It's
No
like a
double or
penalty
nothing.
shootout.
Should we let them do double or nothing on this
let's
one?
do
Right,
double
okay,
or
double or nothing.
Okay.
So, Tim and Sam, Jupiter is 1,000 times the mass of the Earth.
True or false? Is that the... It's probably about that.
It's very big. Kind of almost wonder if it might be bigger than that. Because
that's
how many
probably
Earths
right.
can you fit in the big red spot? That's like some huge number
Oh,
as
that's a
well.
lot, isn't it? Yeah, I think
So-
we should say no, it's
What are you gonna
bigger.
go for?
I think it's no, it's
You're
bigger.
going no. You're
No,
going,
it's bigger.
you're going no.
Oh,
It was the right thing to gamble and go double or nothing, because actually you were right for the wrong reason. Jupiter's only about 300 times bigger, more massive than the Earth. And do you know how we, Adam, physicist, do you know how we know that?
Probably how fast it goes around the sun. We can.
Not bad, actually. The reason that we know that is because we've got very accurate measurements of the moons of Jupiter going round, and you can infer, because we know what the moons are doing, and we know their orbit, we know how fast they're going and how far they are from their host planet Jupiter, so you can work out what the mass, therefore, of Jupiter must be by relating it to the Earth. So it's about 300 times the mass of our own planet. 318, actually, is the close number for that. So that means we've got a tie-break situation now. So what this means is I read you a statement. You have to work out what you think is the number closest to the answer. And if you're the team that's got the answer closest to the number written down in front of me, you get the point, and therefore you clinch the game. So the question is, what's the lifespan of the average tiger?
I'll start with a number. You can say more or less.
Yeah, looks about right. We're going to hit it on...
Adam and Leon, got a number?
We have.
Okay, so we'll just toss a coin. Tim and Sam, what's your suggestion? What do you think?
We've done a last-minute change, and we're going for 30.
30 years, says Tim and
no.
Sam. Liliana and Adam, what do you think?
We actually wanted to say 30. Now we are going with 35.
You're going with 30?
Yes.
You sure? You're going with 35?
Yeah.
Yes.
Okay. Sam and Tim, you are the winners. You clinched victory from the jaws of defeat. The answer's going to surprise you. It's 15 in the wild. Same rough life expectancy as your average pussycat.
go lower.
Naked Scientist Big Brains of the Month. Well done. Give yourselves a round of applause, Sam and Tim. Now, our What Am I quiz is still running, of course. We're asking you, what is this creature? We told you at the beginning, they're mainly between 3 and 15 centimetres long. They have a tail, which is about half as long as their bodies. They're on every continent, but not Antarctica. Your next clue is there are loads of different types of these animals, including cat ones, leopard ones, and Mediterranean ones. Anyone any the wiser? Anyone got any thoughts running through their minds?
Lizards? Some form of lizards? No?
Speculation on lizard there. Okay, well, we'll find out with another clue later on in the show. Next, though, Adam, question for you. This is from Jed, who got in touch on Twitter at Naked Scientists and says, would it be possible for humans to venture outside the Milky Way galaxy and colonise a planet in a different galaxy?
I think the answer to this is, unfortunately, unless we have some real new technology, no. I'm reminded of the Douglas Adams quote from Hitchhiker's Guide to the Galaxy, which is that space is vastly, hugely, mind-bogglingly big. So if you think that Voyager 1, the satellite which has left the solar system, that travels at about 17 kilometres every single second. That translates to, in space terms, 1 light year, which is the distance light travels in a year. It goes 1 light year every 20,000 years or so. And the nearest galaxy to us is about 2.5 million light years away. That's the galaxy Andromeda. So 20,000 years to go 1 light year. We're going a huge distance just to get to that next one. Even Star Trek, with all its new technology, unless something very weird happened, even they were confined to this galaxy.
So it's a no from you.
Unless we can find a way to make wormholes and pierce through space in an instant, yeah, probably no.
Let's sneak this one in quickly, Sam. Molatello has been in touch to say, during the winter, my feet and my toes get icy cold, even when my armpits appear to be sweating. What's causing this imbalance? In other words, how can I have cold feet, but very warm armpits. Can you help Molatello out?
Okay, so this is rooted in the fact that our bodies control our core body temperature extremely tightly. If you go a couple of degrees higher or a couple of degrees lower than 37 degrees as your core temperature, you're in big trouble. But note I keep using the word core. That's because whilst your core, which will be things like your heart and brain, must stay at 37, things like your fingers and toes can cool down much, much more because they're not critical for life. And so our body will even sacrifice them, and you can lose toes and fingers from frostbite. So in winter, if we go out in a cold environment, what our body does is it tries to protect our core temperature by constricting the blood vessels that go to our fingers and our toes to keep more of that warmth inside. Obviously, though, we're humans and we like to be at a temperature where we don't have to use energy to just make heat, so we wrap up really warm. Now, the body can constrict its blood vessels in seconds using the nervous system, but when you put loads of clothes on, you actually have to actively take them off or put them on if you want to change your temperature. So if you suddenly move from a very cold environment to a slightly warmer one, or you start doing some exercise, your body goes from being too cold to too hot. And so it starts to kick in processes to lose heat so it doesn't become too hot, hypothermic. And that includes releasing all the blood into your freezing cold feet, but a bit like when you turn the kettle on, it doesn't instantly boil. It takes a little while for that hot blood to warm your toes back up, but you'll be sweating.
Thanks very much for that very clear answer, Sam. Now, we invited you on the programme earlier to try an experiment in which we said put a handful of nuts into the bottom of a glass jar, half fill it with rice, and then put the lid back on and give it a really good shake. With us is Amalia Thomas. She's a mathematician at Cambridge University. She's actually going to take her research on this subject to Parliament as part of a competition called STEM for Britain. So we are your practice run, effectively, Amalia. You've got your jar of nuts and rice in front of you. Please give it a shake, and then we'll ask the rest of our team or panel to comment.
All right, thank you, Chris. Adam has prepared this jar, thank you very much. And as you might be doing at home, I'm shaking it really well. So I only
it's worked already.
Yeah, 3 or 4 shakes. And can you tell me what you see?
The nuts came on the top?
Yeah, the nuts came to the top.
Yeah.
So this is a phenomenon that happens in granular systems. These are systems that are made of small, solid things, particles, in this case, rice and nuts. And it's a very interesting thing that happens in granular systems only, that the large materials will always come to the top. So this is called size segregation.
Would that work, Amalia, if the nuts were really heavy? So if I had ball bearings in there, would it still work?
That is a very good point. Size segregation is only one type. There are other factors which contribute, and one of them is density. So if it's larger but a lot denser, it would still not rise. Another factor is, say, surface properties. So if it's very rough, it will go up faster.
And what's the physics of that? What's actually driving that? Because that was extraordinary. All of the nuts are now perched on top of the rice, all of them, and it was within 2 or 3 shakes. It was phenomenal. So why does that happen?
Well, that is what my PhD is about. Yeah, this is something that is still not completely well understood. You might think that the smaller particles are more likely to fit into gaps, so they fall. But here we've only got a few big ones, and they're pushed upwards. The key to that, and for this I'm going to make an analogy with fluid systems. So say with a mudslide, this would not happen in fluid continuous systems because in granular systems, forces are not distributed evenly. What that means is that some granules carry a lot of weight and some of them don't carry any weight at all. And the large particles are more likely to carry weights, and therefore they're more likely to be subjected to forces. And as a result, they're levered upwards.
So it's an average thing, and it resolves that on average you end up with a force being exerted against the big stuff because they're more likely to be pushed somewhere, whereas the small stuff will just slip and slide away and distribute towards the bottom.
Yes, to carry weights than small ones.
Where do we see this same science being manifest in the real world?
We see it all the time. We don't know it. This is actually called the breakfast cereal effect. And for this, I stole my housemate's granola.
You really have got a tub of granola.
Yes. So I've got a transparent tub made with a mixture made by my housemate Emily. In here she's got granola, she's got peanuts, walnuts and coconut. Now, and
it's all nicely mixed up at the moment. There's no obvious pattern to any of it.
And so I put it on a side and I just give it a little shake, and just with that little shake, I am.
She could eat 3 different breakfasts with that now because you've got 3 different layers in there.
So I put this above my head. Can someone else tell me what they see?
the bigger things come up.
Yeah, and all the coconut has gone to the
Yes.
bottom, and it's the same phenomenon. This is sometimes it's a good thing. For instance, this is used in recycling plants when you know that you want the different types of garbage separated. And it's a bad thing, say, in pharmaceutical companies when they want all their active ingredients well mixed. One big interesting application is in Avalanches, which is where I actually study this phenomenon. Imagine you're a free skier, so you're skiing in the mountains, not going through any specific path, and you get stuck in an avalanche. There's a procedure for that. You have to wear what look like airbags, so that if you're caught in an avalanche, you pull it and you suddenly become a big particle, and then you will rise
And you
in the
literally
avalanche.
float to the top of the snow.
You will,
Does
just
it
like
work?
the walnuts. Yeah, they do. Then they save lives that way because, like the walnut, you're brought to the top, and then you're not crushed by everything else that the avalanche is
So
taking
you might
with
be
it.
beaten up a bit, but at least you'll be at the top and findable.
And findable, which is key. Yeah.
Superb. Amalia, thank you very much for coming in, doing a wonderful demo, and one that we could even eat. It looks delicious.
Thank you, Chris.
Amalia Thomas from the University of Cambridge. Back to the questions. Liliana, can you tackle this one for us, which has come in from Katie?
What is the greenest way to power my home?
It's an interesting question. Well, definitely something that is very interesting that I also talk to some of the architect friends of mine is the geothermal energy. But of course, this would require installing special pumps. So if you are willing to do this, and it's basically using the thermal energy of the earth to heat up your home. The other ways are, of course, solar energy is interesting, but then again, in the production of the solar panels, we are investing lots of energy in making these materials and making them cleaner. So it's then a question of processes that are maybe not so green that are going into the production. Natural gas seems to be still okay. And of course, this depends on the quality of the gas. So this can also be used. But I would go for a geothermal energy if I had a choice of, designing my own home.
Sam?
I was reading a recent article that actually suggested wind power might be a lot worse for the environment than we thought because the turbines are so large they end up mixing different layers of the atmosphere and actually leading to driving processes that cause global warming. So I think this idea of having different levels of cleanliness of what we think of as renewable or clean energy is really interesting. So you think geothermal's the best?
Yes. So, I think the problem is really that we need to take the whole process into consideration. That it's not only enough to see, okay, this is something which is done seemingly renewable, but you have to calculate and look at the whole process. So I would go for geothermal energy for now.
We are almost out of time, so we better put people out of their misery and reveal what this thing is that we've been asking about throughout the programme. The last clue, off the end of, we said it was 3 to 15 centimetres long, tail half as long as body, on every continent apart from Antarctica, lots of different types of us, cat ones, leopard ones, Mediterranean ones. Last clue, we're known for our ability to climb walls and even run across water. So what do you all think this is? Anyone know?
Is it a lizard?
Sort of.
A gecko?
Tim's got it. Yeah, it is. It's a gecko. Yeah, it's amazing, isn't it? They're extraordinary because if you look at the feet of a gecko, they're covered in lots of tiny hairs called setae. And these setae, because they're so tiny, they interact with the surface at the level of the individual molecules on the surface, and tiny changes in charge on those hairs cause electrical attractions called van der Waals forces between the foot of the gecko and the surface, enabling it to run up vertical walls and even across ceilings. And it's using electrical attraction to hang on to the ceiling. And in fact, people have used the same science now to exploit that in order to enable us to do a similar phenomenon with other household objects now. So people are making gecko-inspired devices of various sorts. So there you go, Tim. You get a bonus mark. You won the quiz,
Yes.
and you've worked out what this mystery thing is.
I think that's good. The mathematician who does tech got the animal answer.
Well, from that, Don's been in touch on our forum, nakedscientist.com/forum, and he says, should I worry about EMFs, electromagnetic fields? I keep hearing claims that electromagnetic fields from cell phones, in particular fears about 5G, cell towers, smart meters, even LED lights are harmful. These harms can include dirty electricity causing cancer, killing or chasing away birds and wildlife, infertility. How fearful should I be, and how cautious do I need to be?
Well, it's a very long and detailed question, and the short answer is no, you don't need to be worried about these, and that you shouldn't get yourself in a bit of a state thinking about them, because electromagnetic fields are in so many different things. You see them in mobile phones, they come off microwave ovens, they come off Wi-Fi routers, computers, the sun. So if they were this terrible conspiracy against us, we would have spotted them by now, because they are all over the place. So what actually is an electromagnetic field? Well, it's a sort of combined word of an electric field and a magnetic field, and you can think of them as just regions of influence. An electric field, for example, will manipulate an electric charge, a particle that is electrically charged, and a magnetic field will manipulate something that is magnetic. And the way that we think of these in terms of whether they're harmful or not for us is in terms of how powerful they are and what they might actually do to you. So the majority of electromagnetic fields that you come into contact with are what's called non-ionizing. So these are like your Wi-Fi routers or your mobile phones, and things like power lines as well are all non-ionizing, and that means they won't do any damage to you, and there have been study after study after study that has looked at this, and you're absolutely fine. Now, there are some electromagnetic fields that are actually bad for us. Think things like ultraviolet rays from the sun. We know that if you stand outside in the sun for too long, you get sunburnt, and that is because ultraviolet rays are not very good for you, and also X-rays in medicine are also not very good for you. So if you limit your exposure, you're absolutely fine, but if you had too much of them, then you could be in trouble.
Very comprehensive. Thank you, Tim. I will use my phone with impunity on that basis. I think the answer is that we're doing a massive experiment on the scale of the whole world, aren't we? There are more smartphones and mobile devices now than people on the planet. So everyone's using them at some point, pretty much. And we have got really good exposure data because we know how long, because most of these devices are phones, how long people are spending on them. And so we actually know roughly what people's doses are. And so people are beginning to relate any health outcome with exposure and looking for a relationship. And am I right in saying I don't think yet we've seen one?
Yeah, absolutely. Every now and again a study surfaces that says, oh, there's a big issue with mobile phones or mobile phone towers. But when you look into it, they are very, very small samples that you can't really make many conclusions from, especially when you compare them to the fact that there are hundreds of studies that have huge samples and huge amounts of data that say otherwise. So if we're going to find that they turn out to have a bad effect, it will be from one of these big studies, not a tiny little one you find on a Facebook group on a strange corner of the internet.
Well, into outer space now. Nigel's got this question for you, Adam, and he says,
why doesn't the enormous vacuum of space just suck all of the atmosphere and oceans off of planet Earth?
There's two reasons for this. The first one is that Earth is really big. There's a lot of atmosphere, but there's a lot more Earth. And gravity means it will just pull all that air in and pull it in so strongly that it doesn't escape off. Little bits might bounce off the very top of the atmosphere and fly away, but so few that we're going to be fine breathing. The other one is that it doesn't actually hold that much. Space is roughly defined by the Kármán line, which is about 100 kilometres straight up. So that's an hour at motorway speeds in a car. That seems like a lot, and we say it's a lot. Things like the sky's the limit. But if you think that the Earth is about 12,000 kilometres from one end to the other, but space is only 100 kilometres up, it actually isn't holding that much atmosphere. The atmosphere is a tiny little shell. So a giant Earth can hold a tiny shell of atmosphere with all its gravity.
And that's the reason why it doesn't all get pulled off into space, because there is sufficient gravitational pull on those molecules to hold them against the Earth's surface. And so they don't just whip off into space.
Exactly. There's too much gravity pulling them down and compressing them against us.
Because one other argument was that Mars used to have a nice atmosphere rather like we've got, but that having lost its magnetic field, possibly because it cooled down because it's a much smaller planet, that magnetic field loss meant that the wind coming from the sun, the solar wind, was then able to pluck away, slowly eroding away the atmosphere of Mars. And so it turned into the prune of a planet that we've got today. We luckily have our magnetic field, so we're protected.
Yeah, that's it. We've still got our shield holding our air to us.
So we've got gravity hanging onto it and the magnetic shield protecting it.
And all that together means we still get to breathe.
Which is nice. Adam, thank you very much. We must leave it there. Thank you to all our guests. We've been joined this week by Tim Revel, Liliana Frooke, Adam Murphy and Sam Virtue. Thank you to Katie Hayler and Izzy Clark who put the programme together. Are you a budding broadcaster or a promising producer? Because if you are, and science is something that you absolutely love, we want to hear from you. We have an opening in our team that might be a perfect fit for you. You do need to have a science degree or higher to apply for this, and you've got until the 14th of March to do so. The details are on our website now at nakedscientist.com/job. That's nakedscientist.com/job. Do get in touch. Now, next week, from medieval metal to revolutionising rubber, we're going to be reimagining our relationship with materials. Do join us for that. The Naked Scientist comes to you from Cambridge University, where it's supported by the EPSRC and Rolls-Royce. I'm Chris Smith. Thanks for listening, and until next time, goodbye.